Welcome to your 11th tutorial in Discrete Math 2, and now we're going to talk about discrete random variables, and that is the probability that a favored outcome happens x number of times. And the representation for it is, the probability for x equals x, capital X equal to a small x, equals f of x. And here, you'll be given like x is equal to 1, 2, 3, 4. So all you're really doing is you're replacing x with these numbers here into the function f of x. So let's see if you throw a coin and you want to count the number of tails that you get. So tails is the favorite outcome. So let's see. Tails is the favorite outcome. Alright, then the probability that x happens 0 times, so x equals tails. So the probability that happens 0 times is 1 out of 4. So when x equals 0, the probability of x equals 0 is equal to 1 over 4. The probability that x is equal to 1, so here you have 1 tails and 1 tail. So the probability of x equals to 1 is 1/2. And then the probability of x equals 2, so the probability of x equals 2, that's equal to 1/4. And else the probability of x equals to anything else, so x equals 0. And notice that all of these sum up to 1. So the probability in the end must sum up to 1. Right, and this is discrete random variables. Right, now I'm going to talk about expected values. And that is, what can we expect from a random variable? Like after a couple of runs, what can we expect from it? And the formula for it is, okay, let's see, e of x, this is how you write expected value of x, is equal to the sum of x equals to, well, it has to pass through all of them, so 0 to infinity of x times p of x. And p of x is just the formula that you're given. So p of x is f of x. And we're going to see this in the next example. Alright, so here the probability distribution of a random variable x is given by the probability of x equals x. So here's your f of x. C times 6 minus x. 4x, 1, 2, 3, 4, 5, where c is a constant. Alright, so the first question is the value of c. So determine the value of c here. Now remember that any probability must sum up to 1. Alright, so if you add all of these up, they should sum up to 1. So for part A, so A, see, the probability of x equals to 1. Alright, so we have to plug in each number here. So we plug in 1 instead of x, and that's the probability of x equals 1. And then we plug in 2 into x, and that will be the probability of x equals 2. Then you plug in 3 and so on. So let's plug in the numbers from 1 to 5. So you have c times 6 minus 1 plus c times 6 minus 2 plus c times 6 minus 3 plus c times 6 minus 4 plus c times 6 minus 5, and that should be equal to 1. So equals 1. Alright, so here we have 5c plus 4c plus 3c plus 2c plus c is equal to 1. And that gives us, let's see, 3, 6, 10, 15. So that will be 15c equals 1. That will give you c is equal to 1 over 15. Alright, so now we found the value of c. So the formula now is probability of x equals x is equal to 1 over 15 times 6 minus x. Alright, so b now. The probability that x is greater than or equal to 3. Alright, so b, the probability that x is greater than or equal to 3. Okay, and that's just going to be everything after 3. So you plug in 3, 4, and 5, since that's what you're looking for. So that will be equal to the probability of x equals to 3 plus the probability of x equals to 4 plus the probability of x equals to 5. And for this one, you just plug in 3 into the equation, so 3 here. For that one, you just plug in 4 instead of x, and here you just plug in 5 instead of x. So you get 1 over 15 times 6 minus 3 plus 1 over 15 times 6 minus 4 plus 1 over 15 times 6 minus 5. And that will give you, let's see, 3 over 15 plus 2 over 15 plus 1 over 15, and that is 6 over 15. Then you can just simplify this down to 3 over 5. Actually 2 over 5. So 2 over 5. Alright, and that's the probability that x is greater than or equal to 3. Okay, and now we have the probability that x is equal to 2 given that x is greater than or equal to 3. Alright, the probability of x equals to 2 given that x is greater than or equal to 3. Alright, now notice that 2 is smaller than 3. So if x is greater than or equal to 3, then the probability of x being equal to 2 is 0. So this is equal to 0 because if we're given that x is greater than or equal to 3, then that implies that x can never be equal to 2. So that probability is just 0. It can never happen. However, if it's the probability of x equals to 2 given that x is smaller than or equal to 3, then this just equals to the probability of x equals to 2 divided by the probability of x smaller than or equal to 3. Alright, so now you have this, and you can just plug in 1 over 15 times 6 minus 2 divided by the sum from x is equal to 1 to 3 of 1 over 15 times 6 minus x. And that will give you the result after you solve it. Alright, I'm starting to run out of time, so I'll just go through the last question. So you have the expected value of x. So remember the expected value, e of x, is equal to the sum from x equals to 0 to infinity of f of x times f of x. And our f of x is equal to 1 over 15 times 6 minus x. So you just plug in that number here. So you have e of x, the expected value of x, is equal to x times 1 over 15 times 6 minus x. And that will be the sum from x equals to 1 to 5. So that will give you 1 times 1 over 15 of 6 minus 1 plus 2 times 1 over 15 times 6 minus 2 plus 3 times 1 over 15 times 6 minus 3 plus 4 times 1 over 15 times 6 minus 4 plus 5 times 1 over 15 times 6 minus 5. And that will give you, alright, just let me calculate this. Alright, and that will give you 2.33333. And that is how you find the expected value of x. So all we did was plug in all the x's that we have. So in the question, we had x is equal to 1, 2, 3, 4, 5. We plugged it into this formula and we multiplied it by x. And that's all we did, and we summed them all up. Alright, I hope this video made some sense, and if you have any questions, please leave a comment. Please don't forget to rate, comment, and subscribe, and I'll see you in the next video.